let's talk a little bit about point sources and spherical waves. For a point source, spherical waves radiating outwards from that point source will be seen. I can try to draw it here. So we have a point source in the middle. The waves generated from this point source will be radiating outwards. If you think about a child standing in a swimming pool and jumping up and down, these are the waves that are generated by that disturbance. So the intensity of the waves at a position away from the point source can be written as the power of the source divided by 4 pi r squared, where this is the power from the source and r squared is the distance from the source. Now this is because the surface area of a sphere equals 4 pi r squared. So this is really just an expression of energy conservation, because obviously as the wave spreads out, the area it covers gets larger, so therefore the intensity has to decrease. This is what's called an inverse square law. Intensity is proportional, and this is this proportionality sign again, to 1 on r squared, where r equals the distance from the source. Now, it's useful to know the following. If we know the intensity and the distance, we can take the ratios of these relationships and work out the intensity without needing to know the power at the source. I'll show you what I mean. So if we say we have intensity 1 equals PS, the power at the source, divided by 4 pi r1 squared, and somewhere else we've measured intensity 2, and it equals the power at the source divided by 4 pi r2 squared. Now we can take the ratios of these two things, so intensity 1 divided by intensity 2, and we take the ratio of the other side, so PS 4 pi r1 squared divided by PS 4 pi r2 squared, and if we're dividing by this element here, we can just turn it around, multiply it out, and we can see it a bit more clearly. Now we can cancel out the power at the source and our 4 pi's, and we're just left with the ratio of the radius. So we have r2 squared on r1 squared. Let's write this out over here. So the intensity ratio I1 on I2 equals the ratio of r2 squared over r1 squared.